Okay. Coming to features of Java, there are many features of Java. Where yesterday we discussed it on simple. Now let's discuss on OOPS and remaining concepts. So OOPS, I will be taking more detailedly in more detailedly as we do a lot of coding there. Before going to OOPS, I will be covering platform independent, secure, and robust, and these all the remaining things. Then I will be going on to OOPS principles. Okay. Before going to that, let me just recall you what we discussed yesterday. Uh, Let me put on some questions. How do you compile a Java class? What is the command to compile a Java class? Vishnu.
Yeah, Java C space that file name dot Java.
Oh, okay. And how do you run the Java class?
Java space that file name.
Yes. Without any no need of any extensions, it would take the dot class file. Okay. That is the basics. And coming on to platform independent, we say Java is platform independent because if you create some code and if you execute it in different processors or in different platforms, let us say my my Windows my Windows is running on Intel, and your Windows is you are taking the same code and placing it in Mac. Okay, and if you are trying to run it, Mac OS is different, right? Even its processors are different. Even its OS is different. So the thing is like Java is more platform independent because it automatically takes care whether whatever the platform it is, it automatically takes care by itself. Why it takes care by itself? What is the future? Why they did it? How they did it? See, everyone will install Java according to their OS. For example, if you are installing Java in your Linux, you will install Linux version. So Linux version will automatically install JVM. So whatever the code that you run would be executed and compiled by JVM and will be run by JVM. So whatever, even though it is Windows, even though it is Unix, even though it is something, JVM is common there. When you download Java, you means you are downloading JDK. It means you are downloading JVM. So JVM knows how to compile it and how to run it. So you are using everything as a same. Okay. So the binary code that it converts would be again read by JVM, and then it is processing. So even though there are different OS like Windows, or even though it's an Macintosh or Linux, because JVM is always same, it knows how to read the bytecode and it processes it and gives you the output. Because of this feature, platform independent, Java is also on those days. C and C++ doesn't support such feature. So Java took a prominent role because of this. Once this thing got into implementation, so it was very useful for all the users to use at any platform. Okay, uh, coming on to the secure, or coming on to the secure, we say Java is secure because the code that you execute is again run in JVM. So it is binded with JVM. No others would be able to read it. The bytecode that is developed by JVM would be read by itself. So no one, if I open those and see nothing, I can do that until and unless I have JVM. So that is the one of the main importance why it was why we call it as a secure. Okay, robust means strong because there are no pointers in Java. So memory leakages and such things were not there in Java. So they call it as a robust. So coming on to architecture neutral. So architecture neutral is like, see, if you are writing your project with one architecture, or if someone is writing something with architecture, with some different architecture, Java never minds it. It just reads the code and compiles it. Oh, sorry, I forgot to share my screen. Okay. Okay, I hope you. Sorry for that. I forgot to share my screen. Okay. When we say architecture neutral, so let me show you again. Platform independent. You understood, right? It works on different OSs. OS. So this is platform independent, secure because of JVM. It is bind in within JVM, so it is secure. Robust. Java is strong. So we call robust is nothing but we say it is a strong. So we call it as a robust. Architecture neutral means however you write your code in any architecture or any way, Java reads it as a normal code and compiles it according to the way. So it never thinks, oh, this is some different architecture. It automatically reads whatever the architecture you give it. It reads it and it processes it. So we call it as an architecture neutral. To be more specific, okay. To be more specific, architecture neutral means if you see Windows has updated its processors with different processors. For example, I have i3. There is an i3, i5, and there are Mozilla processors. So even though you take the code and run in different processors, okay, in that case also it compiles the code as you see the same output whatever the way the architecture was designed, or anything in different processes also it works in the same way. Coming on to portable. Portable is nothing but taking your code from one place and placing it somewhere and seeing whether it is working fine or not. Normally, Java is very good at that. If you remember, in our real-time projects, what we do, we create a var file, take it and place it in their server and run it, right? That is the easiest way for portable, what we call it as. Just taking all the things from one place. If project was in UAT, we move it into some other server. We move it into maybe everything is Linux. Even though it is different, also the code would be working fine. That is what we call as portable. Portable features are very. Portability can also be said like this: like portable is equal to platform independent. Platform independent plus architecture neutral is called as portable because platform independent means as I told you, if they are with a different OS, where architecture neutral means if they are with different processors like Windows, i5, Mozilla. So if both these features we have it, so we call it as a portable. So if it satisfies both, we can move it to any server anywhere. So it is Java is called as portable. Okay. Okay. And coming on to dynamic, it's a just normal way how we say dynamic. Uh, how to say dynamic is like okay. Uh, okay. How why we call it as a dynamic is like when we have a memory allocation for any objects, or see when you create an object, when you create a class, when you run the class. Yesterday I showed you there is a memory being allocated. Uh, that memory which is being allocated or is done in two different ways. One is static and dynamic, which is called as static memory allocation and dynamic memory allocation. Static memory allocation is when you run the code at compile time, you allocate memory. When you compile a code, you create the objects and allocate the memory for it. But dynamic is like when you run it, only then the objects gets values. For example, let us take yesterday code and show you. Now, it's not so clear for a dynamic and static, but let me just try to explain you to make you understand. Don't take it too complicated, but just try to see it in this way. So if you see here the code, first if I compile the code, what happens? Here no variables are there, but for suppose if I create a variable called int x equal to 10, okay, when you compile the code, this variable x will have value 10 in it. When you compile it, it only just checks this, and if you place static variable to this is called, when you compile it, at that time the memory gets allocated. Okay, if there is no static, then it gets allocated when you run the code. When you run means when you run java space command. So that is the difference between dynamic and static memory allocation. We do it like in the cases like anyway, static and dynamic we would be reading them much more precise. There are some disadvantages with the static, so we never prefer always using static. Okay, the disadvantages is like unnecessarily memory would be wasted. If you create static here and if you run it, when you compile it, this x will always have value 10. So if it has value 10, this memory got already allocated. Even though you use the code or not, the x value is already stored. So that is what we say static memory allocation. If static memory allocation was already done, it would we say memory is lot of memory is utilized. For example, if I am not using static and if I save this and compile it, x would be a variable checked, but nothing will be allocated. When you run it, at that time 10 value will be assigned to x. First only initially x would be an variable. Now when you run the code, then the value would be assigned to x. So this is called dynamic allocation. Whenever we run the code, if it is memory is allocated at runtime. Runtime means in this slide, if you see, this is compile time, this is compile time, this is runtime. Okay, so if a memory is being allocated at compile time, then we call it as a static memory allocation. If it is being allocated at runtime, it is called dynamic memory allocation. Okay, so the drawbacks with the static memory allocation is like waste of memory space can happen, and loss of data. Sometimes if someone is also writing the code and if they also use a lot of static variables, there is a possibility that static variables data can be lost. Okay, and if they use same type of data variables, like even they use x and if you also use with static, there is a possibility that data is overlapped. So if you assign static int x equal to 10 and if they also do static int x equal to 20, your data would be overwritten. So maximum we would try to allocate it as dynamically, means at runtime. So as much possible as we can, we should try to use dynamic instead of using static variables. If you use dynamically, it's a good methodology. Okay. Anyway, these things I will be covering you in precise. But just remember that static and dynamic memory is nothing but static memory is allocated at the time of compile time. Dynamic memory is allocated at the time of runtime. So Java is dynamic because it has an option of allocating memory even at runtime. So we call it as a dynamic. Got it, Vishnu? Vishnu?
Yeah.
Okay. Okay. Coming on to interpreted. I will explain this thing in more precise in future. So anyway, when we deal with these topics, we will be getting that what interpreted is. So I will not cover it now because anyway that would be covered. Uh, High performance, as you know, Java, because it's a byte code, it executes very fastly. Okay, so we call it as an high performance. Okay, coming on to main important topic is multi-threading. Okay, when we say multi-threading, it's a nice concept even to understand in a real-time world. So basically, what is a thread in Java is nothing but a flow of control. When you say thread, it's a flow of control. When I say, okay, what is meant by thread is like thread is a flow of control. When you say you are performing one task, that is called a thread. It's nothing but a flowing. It's a flow of control. When I say calculate the sum of 10 numbers, so doing this complete process is called a thread. Okay, multi-threading means many flow of controls happening at same time. Okay, for suppose, let me tell you a good example. Multi-threading concept is like basically what we do is we perform many actions at single point of time. You hear songs and try to code. You hear songs and try to write a letter. You hear songs and try to drink water. You hear and even in laptop, songs would be playing at background. Okay, you would be writing something on the screen, and at the side, if a new mail comes, a new mail pops up. These all things are happening at same point of time. And one more thing, if you are trying to copy a file from one movie from one folder to other folder, then copy also happens in parallel time. So earlier, earlier in the older times, whenever one task is being performed, we used to wait for it. Okay, until unless it gets completed, means one thread gets completed, other thread won't execute. So with the Java multi-threading concept, we can also write our own code to run parallelly. Running many processes parallelly is called multi-threading, many flow of controls. Okay, so you if you write a code saying, okay, song should also come at one time, mail should come, these things should come, you can write code such a way. That facility we have with multi-threading. Got it? So basically, threading is nothing but flow of control. The code that you write is called front thread. That means the thread that you write executes, complete code executes within just normally. If you see this code, in this code, only one thread got created at the front end, which is just assigning value x and printing the statement, the main thread. Because we executed main method, the main thread would be ran at the front end. But at background, Java automatically invokes garbage collector. Okay, we are not sure at what point garbage collector runs, but it always executes at some point of time. So basically, for any program, there would be minimum two threads running. One is the your code thread and background garbage collector. We are not, but we cannot say garbage collector is running at this point of time. It automatically gets invoked by JVM. We never invoke it. So multi-threading is a basic concept that runs Java. Threads are always there. If you write single code doing only one functionality, we say only one thread is running at front end. Background anyway, JVM takes care of garbage collector. It takes care. But there would be situations like, for suppose I got a project like stock market. In stock market, what happens? Thousands of people will watch a share and they try to buy the share, sell the share, place the order for the share. All things happens at one point of time. So we should write code such a way that we should always maintain where we are getting orders, in what we should place them in the order. For example, you ordered from US buying one ICICI share, okay, for 10 rupees, and you placed the order. I also placed the order 1 second after to you, millisecond after to you. So it would maintain your order as a first and my order as next. So it should maintain all the things. So when that ICICI bank share gets with that price, first, because you placed your order first with that price, you should be given a chance to pick that. So it would automatically buy the share for you and give you. So your account should be credited with your share, and my account should be credited after your process, my account after, like that. Everything should happen parallelly. When a share is bought by you, total number of shares shown on the screen should be decreased by one. So if you see in that process, and also the money detected from your account should also happen. This is one example. One more example. Whenever you withdraw a money, you get a message parallelly into your mobile. Whenever you post money, you get a message. So there are places like multi-threading concepts would be coming into picture, where you should run 2 to 3 process at same point of time. So that things can be achieved only through multi-threading. So this feature is there in Java, where we can write many processes running at parallelly at the same point of time. that is called multi-threading. It's a nice concept and it's a very important concept. So I gave you a basic introduction to that. Anyway, we would be covering it as a separate minimum. I think we will cover minimum 4 to 5 classes on multi-threading. It's a very important concept, and we will be having a lot of programs to do on that. Okay, on at least basic programs. So background thread in multi-threading is also called as parent thread, and front threads are called child threads. Okay, uh, uh, that is the main concept for multi-threading. When you come for distributed applications, I think you might be knowing about distributed applications. This is much prominent these days. What distributed application is like, I will explain you with an real time example. Let me just open the paint. What is distributed application? So before starting, let me just draw a small diagram. I designed an application such a way, if you see the screen, this is my application. I designed an application. This is my computer C1, this is my computer C2, and this is my computer C3. Okay, so one of my computers sent a request to my server. Let us say this is a Google system, Google server. Okay, for suppose Google. Okay, so it sends the response back. If someone Google something, it sends the response. Same way, if C1 sends a request, it gets a response. If C3 like the same way, we get the response for that. So arrow marks would be normally on both sides. So earlier, when the initial developments of any servers was like this is normally called as centralized application. This way of designing an application is called centralized application. Centralized application is like we would have only one center of point where we get contact. Okay, so different people will come and push on this server and get the data. So what's the problem with this server? Initially they did it like this, but what problem they found it is like, for every server we have limited ports. Like for example, how many phone calls can be done in same point of time in India through BSNL? There is a limit, right? Even how many people can connect to a server and get the data? There is a limit. It's not like unlimited. In one server you can do it. There are only few ports. Only if one is requesting and one port is busy, the next request would go for the next port. Like that, it would be distributed on the complete ports. Once if all the ports are busy, if someone is trying to send the response, they would get an error. And if these people are increasing, even though they are busy, server will be down. I think you know such scenarios, right? Because of overload. Vishnu, you got it right, what I'm trying to say?
Yes.
Yes. So there is a drawback if we have a centralized application. If a load is increasing on it, automatically server will go down. So we see WhatsApp is not working for 1 hour or 2 hours on last Saturday, or some website got blocked or got is not working properly. Server was down due to overload. So every server has its own limitation. Like it can only hold maximum number of requests. Every server has it. Depending on the ports, it has availability. Same way, when on New Year our phones gets blocked because all are trying to engage on that. Until and unless a few people put down the phone, some other people won't get a chance of working on it. It's not only to a software, even for a hardware also they would face the same issue. So in order to come out of this scenario, they came up with an application called distributed applications. Okay, what is how distributed applications would be? Let me just copy this into the slides. Okay, this is centralized. And now let me draw a distributed application. So same way we have in distributed application we would have servers, many servers. Like Google has 7 servers all over the world. Okay, and we would have clients. Let's say this server is in G1. Let's say the server is G1 server in West. It's in West. G2 means G2 is present in East. East means like in China, in one server in America. So we G2. Sorry, this is G2. Okay, and let us make it as G3. So East. Okay. So for suppose there are different clients who are trying to uh, access the server. Okay, let's say C1, C2, and C3 and C4. So first, if C1 is trying to access the server, it would be checking out the nearest server which is available for it. Okay, it has an access to access G1, G2, and G3, but it would be checking only the server which is nearest to it. Nearest to it doesn't mean uh, in the distance wise. It means which is free. For suppose whichever server is free and is having a chance of giving the response, that is called as nearest server in software. Okay, in software words we say that. So for suppose if the server is always busy, it is very busy, when it got a request it would directly go into G1 and gets the response and shows that to the client. And the Google will make sure that all the servers are in same page, or there may be some delay in the content or something. It's their architecture how they do it. But normally, in order to serve the services for a client, they do with a distributed way, in this way, such a way that they have different servers and they can communicate. Same way with C2. C2 client can also communicate with uh, G1, G2, and G3. Okay, same way C3 also can communicate with the G1. C3 can also communicate with G2, and same way with G3. And C4 client 4 can also communicate with the G1, and client 4 can communicate with G2 and with the G3. So if you see here, what really has happening is like uh, services for doing the job has increased better. Okay, and the way we handle the thing is much easier. Earlier, whenever it gets overloaded, we used to fail. Now it's and we increased the services to 3, more people can access it, right? And even the work is even distributed on different systems. So when one is working on this, if it has a chance of giving services, C2 can also work on the G2 at same point of time. But automatically server would make sure that if it is busy, they would have an option to go for a G2 server and get it. Okay, this is the way how distributed applications work. Okay, this is how the distributed application serves. Okay, so uh, Java is called distributed because we can write our programs in such a way and manage this. So there is no problem saying, okay, only wherever we write, we have such facilities to write the code and it works in such a way. Through Java, we can write distributed applications as well. That is why we call it as an distributed. Got it?
Yes.
Okay, this is how we call it as a distributed. Okay. Okay. So now we are done with all, and the main concepts we are lagging is like with hoops. Let me just give me 1 second. Okay, Vishnu, let's move on to the concepts called OOPS. OOPS is nothing but object-oriented programming. Okay, object-oriented programming is a methodology that was already exist, and Java uses this methodology to do the things. Okay, so what the main concepts of object oriented programming, when you say Java is an object, why you say Java is an object oriented programming? Because of this concept, because Java has this concept, so we call it as an uh, so we call it as an OOPS because objects is the base for object oriented programming. Whatever is being designed, we do with an object. Class we have classes, and inheritance we do it with an inheritance, and polymorphism, abstraction, and encapsulation. Everything in these are very important. I would be telling you all the things one after the other, but before going to that, I would just explain you object and class for today, because object and class are the base for anything, even to understand inheritance, polymorphism, abstraction, encapsulation. When you learn the concepts, you will be knowing them. So first, let me define what object is. Object is there are many definitions for object. It's like for the class that you define, we create an object. Uh, the really to say that, first let me explain you class. So once I explain you class, you will understand it. Let me explain you with the code that we started yesterday. So if you see here, now I am explaining you what is a class. A class is defined as group of data members and methods is called as a class. Yesterday I told you that group of data members and methods is called class. Okay. So let me put it in a diagrammatic way. When you say this is a class, in this class you have two sections. One is data members. This is data members, and second is methods. Okay. So data members are like declaring variables on the top of inside a class is called, this is class. Class inside a class, like declaring variables and deploying variables is called data members, where methods are writing a piece of code. In those methods, a small functionality that you need to perform is called as a method. So if I show you the code that we wrote yesterday, this is a class. In a class, we start with, it can be public. For now, remember this as a public class. We should use a keyword called class and write whatever the name we want for that class, and you should start and close within parenthesis in this, and this is normally a class. Okay, this can be a class. In this class there can be data members. Normally in Java, for commenting a single line, you use forward slashes, double forward slashes. Okay, example, int x equal to 10. Okay, so int refers to an integer, string refers to some group of characters. uh, we would be I would tell you what different types of data types we have. That would be our next class, after objects and classes. So this is one, and same way you can write as many as you can. Data members can be anything, like boolean, boolean. It's an boolean flag. Let's say it says a flag, it would be normally true or false. Boolean is always true or false, and in this we have methods. So this is one normal main method. Normally for every method we would have public or finally, and static is a normal keyword, where I told you, right? Static defines static variable, static method. So static is for static method. Void represents whether this method is returning any value or not. Here we are not returning anything, so we represent it with an void. Okay, if you are returning something, then you will represent with some other variable, like into or something. I will explain you that. Main is the main method name. So let me write one more small method called int sum of numbers. My method is sum of numbers, where I have x and y equal to 12. So what this basically does is, like, int x comma int y. Just don't think of much. Just I am writing one retu return x plus y, or you can write it like this: int z equal to x plus y, and I am returning z. Okay, so we totally have 3 data members and methods. Give me one second. Okay. If you see here, we have 2 different methods. One is main method. Method is to where to start the program. And let us say I just want to sum of 2 numbers. So let me just comment this out. This is nothing here. I'm just remodifying the code. Ravishankar, sum of x and y is, and if I call this method, control C here, and if I pass the parameters x and y, x comma y. So what indirectly we are doing is, the main method, I am just trying to print a string saying sum of x and y is, I am calling a method sum of numbers. So what I am passing to these numbers, I am passing x and y. So this method would take x and y, and in this method what operation it does? Z equal to x plus y. I got these values from here, these values, and these values will be here. So what it does is, in sum of numbers, it would search for the method in the complete class whether there are 2 variable sum of numbers, because this name exist with one more method. This method is the same. It comes here and sends this x and y value to here, and this x and y value will be utilized in here, and z would be assigned with x plus y and returns z. So the output for this program would be Ravi Shankar sum of x and y is z. Is z means the sum of two numbers like 22. Got it? Vishnu?
Yeah.
So you understood the importance of methods, right? Why we use methods is like, we group the functionalities into methods and call those methods wherever we need. So in order to submit, we did it here. Somewhere we need some multiplication, we write it into a multiplication and you reuse them. Methods are used as reusability. For reusability, we create methods and write the code. You can ask me, Ravi, why can't you just add it directly here and print it directly? I can do it here, right? Because I have x and y value here, I can write it x plus y here and print it. Yes, I can do that. But what I'm trying to convey is, for same, if you feel this method is an unique, this functionality is unique and it can be used many times, next time somewhere you need to sum up the number again, just calling this method and passing the value will automatically sum and return you the value. This is a basic example. Somewhere you may get not just a sum, you may need to do lot of functionalities. Let me show you here. This is a demo code where where what I'm doing is like, I'm just checking the regular expression. So I'm just writing the code which is related to regular expression in this method. Here one more method I have, get latest files from directory. Here only the latest files, we read the logic, we write the logic to read a directory, get all the files and check that and send it and return the absolute path. Whatever we are returning, we are mentioning the same modifier name here. If there is nothing here returning, if you don't see any return statement in the method, you should place as void. Void means I am not returning anything for this method. So here in the same way, in the main class we would return nothing, so we would place void. But here I am returning z. Z is an integer type, so I am placing integer before the method name. So here the integer would be returned. So a class is nothing but group of data members and methods. Method is nothing but a common functionality that we write, and in order to do that, we should create a method name prefixing with the return type, and in between open and curly braces, you should mention the complete code what you need. So this is how you write a program. So you got it right?
Yeah.
Oh, okay. So I'm just pinging you this. Just place it as a note. Anyway, I updated this code. I will run it in my local system and show you how it works. Again, same thing what we did yesterday. Okay. Uh, Java C hello world dot Java. So I just compiled. Waiting for the compiler. Okay. It shows me. It shows me error. What errors it shows? It's a spelling mistakes that I did. Here, if you see, this is false, FALSC. This should be false. Boolean is always a false spelling mistake. So it showed me one error saying, oh, you did a mistake. So let me just correct that. This should be FALSC. So this is okay. And second error it shows me is some. Okay. So false issue got cleared. Only I have two errors. Now let me just see what errors it is. Static context. Okay. The one more thing is like, this is related to static. Just remember, just don't mind it. I am just placing static because static variables should be used in static methods. Okay. Now my code will get executed. So maximum Java would give you all the types. C. Non-static variables X cannot be referenced for a static context. Same way, non-static variables Y cannot. There is a rule called static variables should be used in static things. So I should make, because these methods are static, I should make these variables as static. Just that is the thing. Now let me execute hello world. See, you saw that, right? Sum of x and y is 22.
Yeah.
Okay. So okay. So class is nothing but uh, grouping of data members, and grouping of data members and methods is called as a class. Okay, there are many definitions for a class. Just if you go through one more definition, what I can say is like the process of binding data between associated methods in a single unit is known as class. So the group of binding the associated data members and methods into a single unit is also called. Okay. Uh, is called a class. There are many definitions. Uh, okay. The important thing in class you should remember is whenever you define a class, memory would never be allocated. Okay. Memory is only allocated when you create an object. When you execute, when you run this, only then the memory gets allocated. Whenever we just define a class, no memory for these data members. For these data members, no memory will be allocated, but only memory is will be created. Whenever you create an object for this class, at that time the memory gets created automatically. But here there is no, we didn't create any object because we just compiled it. At the compile time we just create the memory here. Now I will tell you how to create objects and something. At that time you will understand. Okay. Okay, this is the about the class. Now coming on to object. Okay, when we say object, the objects are nothing but, in order to create the memory for the class, we need to create an object. So what we say is, whenever you create an object for your class, at that time only the memory gets allocated. Okay, so uh, for in order to create an object, you should have a class. Once class is there, you can create an object. So let me say, the definition of object is the instance of a class is called an object. So whenever you create a class, and if you try to use this class at some point somewhere, then you call it as an object, the instance of a class. Let me show you more in one more example. What I'm doing is I'm just copying the same code, but I'm removing all the things internally. I'm renaming this to object creation. I cannot create a class with object because object is an already a keyword. So I just updated with it something else. Okay. What I gonna do is like I will write the same public static void main. I'm removing the complete code here. Okay. What I would do is my goal is to use the okay, my goal is to use the hello world class as an object in some other class. Let me first save this. Whenever you save, you should also always remember that you should save with the Java. So I'm just updating with the object creation Java. I just saved it. Now I am trying to update it with how do you create an object? You remember, right? What did I say? The definition object. The instance of a class is called an object. There are few different ways to create an object. Okay, the first basic way of creation of object, first way is with new keyword. Okay, new keyword, how you create an object. For suppose if you want to create an object for this class hello world, what I should do is I would copy the name, control V, and I would create an object variable like identifier, like some name, like let us say uh, HW object. It can be your specific. Okay, you can write anything. And if I write new, control V, hello world of this means I created an object. Once you write this in this way, at this point of time you created an object. When you create an object, then it goes to this code and creates the memory allocation of all these. Okay, this is the way how you create an object with a new keyword. So indirectly what we are trying to do is we have lot many classes and we are trying to utilize the classes that we have written. Same way, how are we using the API? Already defined classes we are using, right? If you see here the code I showed you yesterday, file class. What we are doing? File. I am writing one word called dir equal to new file of and passing the path. So this is the variable that they are expecting in for a file class. Once I do that, I am creating the object for this. And this object again we read the files. So if you see there are everywhere whenever we utilize some classes, we write within, we create the object for them. Got it, got it, Vishnu?
Yeah.
If there is any doubt, let me know, because I would be expecting everything is being understood by you. So you understood the importance of object, right? Why we use object is to create the memory allocation of a class and execute them. You can write just this code hello world and you can execute it. But when you create large codes, you would be getting, you will end up with writing many classes. In order to use the already existing classes, you need to create the instance of that class. When you create the instance, you should, which is nothing but creating an object. Creating object means calling that class name space some name equal to new of this class. Why I am using, I am not passing anything is this class expects nothing. So I am just running it in such a way. If I save it and execute it here, okay, let me show you Java C object, right? Object creation.java. Okay, now let me run Java object creation. So that got executed. You see nothing happened, but really what happened here is this complete hello world got all the values for these things got executed. We didn't display anything because I didn't call any other methods. Let me call hw dot hw object dot main method. I am trying to call the main method. What happens for this object? Please go and see the main method with a method name this. So whenever you create an object, in the object is being created and memory is allocated for all the data members, like x gets 10, y gets 12, flag gets flag, and we have these methods. And in the next line, when you say object dot main, it goes to the object and sees whether there is a main method or not. Yes, there is a main method. It goes here and sees, okay, system.out.println. Okay, let me print whatever the content that is present here. Ravi Shankar sum of express y is sum of numbers. Again, this is a method. So it goes here with the values x and y and sums it and returns it. So here you get 22. That gets printed. So if I save this and run it again, because I modified the code, I'm just trying to, okay. Uh, mm, okay, I should not use the main method again here. So let me just modify this with sum of numbers. 22 comma 5. I'm just passing the value here and saving it. Okay, now I am using Java. Sorry, dot class should not. Oh, again I forgot to place one more thing. Why I forgot? I didn't write any sysout here. Even though I'm returning it, I should write some. I should get the value here, right? I'm writing system.out.println because I am not using main method now. I'm just using directly the other method. See, here I am not calling the main method. I am calling the sum of numbers, this method, directly from the object. So I am passing the values here. These values get added here and summed here. Okay, let me just save it. See, you got 27. Because you wonder, let me explain you once again, Vishnu. See, how the main concept that I'm trying to show you is I'm just trying to utilize already existing class, create its object, and you call one of the method. I'm trying to call the sum method. If I run hello world, this main program gets executed and it calls this and it calls this method and prints it out. Now my requirement is like I am using an object creation class where I am calling the hello world object. In a hello world object, I am trying to call sum of numbers and I am passing the numbers dynamically. Okay, once I pass these numbers in this code, once the object is being created, this object would call sum of numbers. In this, sum of numbers is this, and I am passing 22 and 5. So x and y would be getting 22 and 5, and I would add x and y, and it will return. Got it?
Yeah.
Yes. Okay. So, mm, okay. One more thing, let me show you. Okay, I'm just saving it. I'm just trying to do one more small stuff. So depending on the requirement, whether to show it in the console or not, we can do it. For here, it is not like we need to. Every program doesn't need something to be shown on the screen. There would be some codes like writing into some text file, uh, reading some content from text file and writing into some text file. Normally, for our normal practice, we just show it in the system.out.println. So this is what we call as class and object. If you know how to write a class and object, you are almost done. You can start coding. Only the thing you need is what are the identifiers you have, what are the data members we need to define, what do we have in Java. Only these things I need to tell you that. Anyway, tomorrow I would be covering the main concept called what are the data types. What data types are nothing but these things: int, string, flag, sorry, boolean. What data types we have in the Java. Once I teach you the data types, then the real programming would be started. So you can write your own program. I would be giving you an assignment. You should try to create methods. You can write everything in only one single method. uh, Once you know all the data types, you can declare your own data types and you can write the code. Okay.
Yeah.
Okay. That's all for the day, Vishnu. Any questions?
Mm, Questions in the sense,
Pardon?
questions means like,
No. Any questions from the class? Do you have any doubts from the class?
yeah,
Yeah, tell me. You can feel free to ask me.
like I don't know when we call a class,
Okay.
why we are trying to a class or how we are going to write a object. I'm totally confused. Like
Okay.
not
Basically,
clear.
don't just don't think of when I should create an object or something. Just to know
And
how to
why
write a class.
and sometimes yeah, how to write a class, I don't know that thing. And see, why are we giving static void main?
Okay.
Because you said static means we are going to allocate the memory at the runtime or before
At
the
the
runtime,
compile
right?
time.
So, yeah. So instead of giving dynamically, why are you giving static? So
Okay.
this type of
Okay, these things I will explain you because still we are at the base. These are why, how, what is system.out.println. I will explain you all these things once I complete the data types. Okay, once I complete the data types, I will write some code and I will explain you line by line. Okay, see, for main method was already defined by Java, so it's mandatory that we should write public static void main. Okay.
First
Uh,
of all, I want to know what is a main method and how many different types of like methods means any sub methods or
yeah, you, it's,
something like that.
see, when main method, I told you now, main method is the main. In order to start a code, you should write a main method. How is my object creation class? See, there are 2 to 3 methods here. If I run hello world, where it should start? It automatically starts from the main. If there is no main method, you should tell hello world where to start. So Java has already defined main. So if you use main method, your code will start from main. That's it. So there is no alternative other than main how to start it. If you are not
Oh,
declaring any class and calling. But here, even though there is main method and there is sum of numbers, I explicitly created object and called only sum of numbers. You saw this, right?
yeah.
So these features you will be knowing once you get experienced how to write a code and those things. I will anyway explain you. First thing, did you understand what is a class?
Class
A
like
group of data members and methods is called a class.
okay.
That is what today we covered only this point, like grouping some data members and methods is called a class. Do you know how to write a class? Yes, just write class. Even there is no need to write public also. Okay, just write a class hello world within double quotes, write one public static void main method with the string args and write something in that. That is a class. Okay, so if your code is getting increased, you may add data members, you may add many methods in that class. Got it?
Okay.
So
Yeah.
basically, if I say write a class, you should be able to write a class. Tomorrow assignment, what I want is you should write a class with a name called uh, fun. Okay, my class name is fun. Let me just point out in a text file. It should be f should be caps and un should be small. And what output I need is you should just print some value called whatever value what you want to write. Print me saying hello, this is fun. Okay, I just need you to print this. Just create a class. I'm just pinging you the things. The second line should be printed in the console. Got it?
Yeah.
Do this assignment. A class name should be with fun, and if I execute the class, it should print me hello, this is fun. Got it? Right?
Okay.
Okay. That's all for today. Uh, uh, if you do this, and tomorrow I will explain you data members. Once I explain you data members, I will go in specific what is this is the this is the syntax, or this is the way how they have defined class should be with class and name, and then you should start with every flower bracket would be closed, and in that you should have data members. In that with the data members you can have methods. If you follow this way, okay, Java would everything would be correct. So this is how they have defined. So we are working on in that way. We would write our code internally as we wish. Okay, so just write a code, whatever I told, and tomorrow I will explain you in specific of data types. Once we know data types, then I will explain you with a different method. So by practice, you would know where to write methods, how to call objects, how to declare objects, how to initialize objects, or something like that. Okay.
Okay.
No. Okay. Thanks then. Thanks a lot.
Yeah.
Okay.